Hello students, let us study today the concept of tangent and normal, how they are related to the derivatives. Now, already you are familiar with the concept of a tangent. Tell me what is a tangent? Tangent is a straight line. Does it intersect the given curve? No, it doesn't intersect. It will just touch the curve in a single point. So, as you can see in this figure, this line is touching the curve in a single point A. Now, this curve is the graph of the function with equation y is equal to x square plus 5. So, this is the tangent and it is touching the given curve in a single point A. So, this point A is called as the point of contact. This is called as the point of contact. Now, how do you define the derivative? What is derivative? Derivative is the gradient, or I can say the value of the gradient of the tangent at the point of contact. That means at point A. Now in this case, point A has got coordinates 2, 9. So what will be the gradient of the tangent? Y is equal to x square plus 5 is the function. So differentiate it. Dy by dx, that is the derivative, x square, derivative 2x, and phi derivative is 0 because it is a constant. Now here put x is equal to 2. So dy by dx will be 2 into 2, that is 4. I am putting x is equal to 2. So 2x will be 2 into 2, that is 4. And hence the gradient of the tangent to the curve y is equal to x square plus 5 at a 2 9 is 4. So that is the first concept. The derivative, the value of the derivative at the point of contact is nothing but the gradient of the tangent. Now, let us go to the next concept, and that is of normal. But before starting with the concept of normal, I'll just revise a small thing with you, and that is nothing but the gradient of two perpendicular lines. So here I'm putting these are two lines. I'm putting a picture here. So these are two lines, L1 and L2. So this is line L1 here, which gradient is say M1. And the another line is here, L2, whose gradient is M2. So what will be the relationship between these two gradients? If the two lines are perpendicular, then the product of their gradients M1 into M2 is -1. Or I can say that the gradient of one of these lines is negative reciprocal of the gradient of the second line. Now for example, if gradient of line L1 is say 2 upon 3, then the gradient of line L2, gradient of line L2 which is perpendicular to L1 will be negative reciprocal of 2 upon 3. How do you find the reciprocal? By interchanging the numerator and denominator. So the reciprocal of 2 upon 3 is 3 upon 2. So the gradient of the second line which is perpendicular to the first line will be -3 upon 2. And you can see if I take the product of 2 upon 3 and -3 upon 2, I will get -1. So if two lines are perpendicular to each other, the gradient of one of the line will be negative reciprocal of the gradient of the second line. So with this, let us discuss the concept of normal. Now basically what is a normal? To understand what is a normal, I am putting a picture here. So as you can see here, again this is the curve with the equation y is equal to x square plus 5. Y is equal to x square plus 5. Now to this curve, a tangent is drawn at point A. The coordinates of point A are 2, 9. And at A, we have drawn a line perpendicular to the tangent. So that is called as the normal. Now in our case, the gradient of normal will be how much? So as you have seen just now, if two lines are perpendicular to each other, then the product of their gradient is -1. So I can say gradient of normal, gradient of the normal into gradient of the tangent is -1, which will mean the gradient of the normal is negative reciprocal of the gradient of the tangent. And since we have already seen that the gradient of tangent is 4, that means the gradient of the normal will be negative 1 upon 4. So let us just quickly revise this concept by taking a simple example. Find the gradient of the tangent and the normal drawn to the curve y is equal to 2x square plus 1 at P, whose coordinates are 1, 3. So, first of all, let us find the gradient of tangent. Gradient of tangent. Now, tell me, how will you find the gradient of the tangent? What gives you the gradient of the tangent? Yes, the value of the derivative at the point of contact. And in this case, the point of contact is 1, 3. So, first you differentiate y is equal to 2x square plus 1. So, dy by dx will be 2 into x square. What is the derivative of x square? 2x. And one derivative is 0. That will be 4x. Now in this is your gradient function. So in this gradient function, put x is equal to 1. That is the x coordinate of the point of contact. And hence dy by dx at x is equal to 1 will be 4. 4 into 1, that is 4. And what does this give you? This gives you the gradient of the tangent. And therefore the gradient of the tangent is 4. The gradient of the tangent drawn to the curve y is equal to 2x square plus 1 at the point 1, 3 will be 4. And the gradient of the normal, tell me how will you find the gradient of the normal? Since the tangent and normal are perpendicular to each other, the gradient of the normal is negative reciprocal of the gradient of tangent. So the gradient of the normal will be negative 1 upon gradient of the tangent, that is 4. So negative 1 upon 4. See that the product of gradient of the tangent and the gradient of the normal should be negative 1. So I will give you a sum for practice. Find the gradient of the tangent and the normal to the curve y is equal to 3x square minus 1 at a point P whose x coordinate is 2. And keep it in mind that to find the gradient of the tangent or the normal, you don't need the y coordinate of the point. So just try out this problem. So I just go through what is the gradient of the tangent, that is the value of the derivative at the point of contact, and the negative reciprocal of the gradient of the tangent is the gradient of the normal, because tangent and normal are perpendicular to each other at the point of contact. So just go through these concepts. Today I have just taken very simple examples to make the concept clear. So next time we'll solve more problems on the equations of tangents and normals. So see you in the next class, students. Bye.